Hi, Rohan. How are you doing?
I'm good, sir. How are you?
Very good. Very good. So today, what do you want to do?
Sir, today I would like to work on the quadratic expressions if A equals 1.
Ax square plus bx plus c, where a is
Yeah,
1.
the standard
So,
form. Yeah, the standard form.
okay, standard form. You want to know how do we factor it, correct?
Yes, sir.
Okay, so we can share the screen. Do you have any questions in mind, or should I just tell you about it?
I think you can tell me about it, sir.
Okay.
So basically, like standard form, all it does is that it tells you what your A is, right? And if A is 0, then you already know it is a linear equation by looking
Yeah.
at it. So the basics I know. How about like finding the vertex on its own? If we
Finding the
consider
vertex.
like it at 0. Yeah.
Finding the vertex. Okay. Okay. Okay.
So do we just multiply everything by 0 and get our
Mhm.
C as?
No, no, no. So we will look into that. We'll look into that. Okay. So let me just share with you a whiteboard, and from there we will continue. Is it okay?
Okay, sir.
Okay. So basically, you would like to understand if I have an equation which is y equals to ax squared plus bx plus c, you want to put a as equal to 1, right? To begin with?
Yes, sir.
In that case, you want to understand how do we write this into vertex form, right?
Yeah.
So the form given to us is called standard form. So this is standard form.
Okay, sir.
The vertex form in general is written as y equals to a x minus, let's say, p whole square plus q. That is the vertex form, where the vertex can be written as pq, right? That becomes the vertex, correct?
Yeah.
So you want to see how do we do this. Okay. So as you are requesting, I'll first put a equals to 1, and then I'll show you how do we do the vertex form from standard form. So y equals to ax squared plus bx plus c. So if I put a equals to 1, I have y equals to x squared plus bx plus c, correct?
Okay, sir.
Right. So you'll see from here, how do we get the vertex form? Let me clear the screen. We'll start once over, all over again. So we have y equals to x squared plus bx plus c. So the idea here is to complete the squares. We call this method as completing squares. The basics is that if I have a plus b whole square, then how does this expand into? You know the expansion of a plus b whole square?
Yeah. So
Tell me.
A plus B whole square, sir.
Yeah,
That would be like A square plus 2AB plus B square.
correct. So in this, if you want to have a plus b whole square kind of a thing, in that case, if you look at this particular expression, x squared plus bx, right? So we have one square, we have bx here, but we are missing this 2, right? And we are missing b squared. You get the idea?
Yes, sir.
So what we do here is we do half of the b value given to us. So we rewrite this expression as y equals to x squared plus bx plus half of b, which is b over 2. We square this. And we subtract the same term. While we do have c already. So we add and subtract half of the coefficient of x.
Wait, sir. So basically, from whatever our BX values, we divide it by half and we square it,
We divide by 2.
subtracting the same thing, right, sir?
Yes, and we square it. So now, if you look at this particular expression, is it of the form, this is a square, right? This is b square, correct?
Yes, sir.
something square. And 2 times this is the center value. So you notice that bx is actually equals to 2 times b over 2, correct? Times x.
2
I have to
times
write
b over 2.
to x. So 2ab, bx.
Okay, sir. And then
X is
from
already there.
bx equals to 2 b divided by 2, sir, right? That
Yeah,
would just cancel out to b, right, sir?
that center term comes, right? So I could actually rewrite this as x plus b by 2 whole square. And we already have this minus b squared. Let me square this. We'll get b squared over 4 minus c. Do you see that? Plus c. So the 3 terms here can be written as x plus b by 2 whole square. Let me show you once again. X plus b by 2 whole square, when you expand, will be what? X square plus 2 times b by 2
b by 2
times x plus b by 2 whole square, correct? Which is x square plus bx plus b square by 4. Is that clear to you?
Okay, sir. So I'm just writing it down.
Yes.
So 2 multiplied by b divided by 2, sir?
Yes. So that becomes bx, right? So we get this bx.
Is it multiplied by x as well, sir?
Yes, yes, yes. 2ab.
Okay.
2ab, right? So a and b both gets multiplied. So all of a sudden, you see we have changed the form of the equation. It was given in standard form and we got a perfect square as one of our terms. You see that?
Yes, sir.
So let me just rewrite this. And we have what? We have x plus b by 2 whole square. And this term, we can take 4 as a common denominator, right? So, and we can do. So if I take, let me write plus here. In that case, we have minus b square, this is minus, over 4 plus 4c. Taking 4 common between the two. So now you see, we have written it in the vertex form, which is y equals to a x minus p square plus q. Where if you compare, you have q equals to minus b square plus 4c over 4. And the value of p is basically minus b by 2. Is that clear to you?
Wait, sir. So p is minus b over 2, right, sir?
Yes.
And q is minus b squared plus 4c divided by 4.
Yeah, since we have a equals to 1 here, right? In this particular.
And that is for finding out the vertex.
Let us take some examples and then try to understand it. Okay, so let me clear the screen now. Have you copied all this?
Yes, sir. So just before you erase everything, so when we have to solve for the vertex, it's just going to be whatever p is of negative b divided by 2. And correct. I'm going to use basically p and q's formulas to find out my vertex, right, sir?
You are right. So, but we'll take some examples and see how we can work, right? So let's take one example. Let's say y equals to x squared plus, let's keep it simple, 4x plus, let us say the number here is 5.
So y equals to x.
So to complete the squares, what will you do? What is half of 4? 2, right?
2, sir.
So you are going to add 2 square and you're going to subtract 2 square. We already have plus 5 here. Is that clear to you?
Yes, sir.
Now you see that the first 3 terms form a perfect square. And therefore, I could write them as x plus 2 whole square, right? See, x square plus 2ab, yeah. 2 times x is 4x, and 2 square is already there. Is it okay?
Yes, sir.
Minus 2 square, which is 4, plus 5, correct? So we have x plus 2 whole square minus 4 plus 5 is plus 1.
Plus 1.
So
then it would just be negative 2 and 1, sir.
Yeah, the vertex now will be at negative 2 and the parabola opens upwards, correct?
Yes,
So the
sir.
parabola opens upwards, and we know that the vertex is at -2 and 1. Is that clear to
So,
you?
sir, what you did was you have converted basically standard form into vertex form to get it. Oh,
Correct. Now you can easily sketch the graph. So this is very, very important. So the significance is what? So what is the importance of this? Let's try to understand. One, you know the vertex, right? And you can sketch easily. How can you sketch easily? Because you know the step also, you know the vertex, and then how will you sketch? You know the step formula, right? The steps from the vertex are A times 1, 3, 5, 7. Do you remember that?
yes, sir. And then you just multiply by whatever your A value is to get it.
A in this case is 1. That means that the next value here will be what?
1
Add
to
1.
the right and 3 up.
So when you go right, that means you are at -1, and 1 up will give me 2. Do you see that point?
2. Yes, sir.
So similarly, if I move one more step, I'll come to 0, and 2 plus 3 is 5. Do you see that?
5. Yes, sir.
So you see at x equals to 0, if I put x equals to 0 here, what do I get y value? Y-intercept as 5. Do you see that?
5.
So it is
Yes,
a
sir.
simple check. So very easy, I have sketched a parabola from the given equation. Is that clear to you?
Yes, sir.
Let's take more examples. And this time we have y equals to half. Okay, I don't want to take, we'll first consider a as 1. Okay, one more example. X
Okay,
plus,
sir.
let us say 3x squared plus 3x minus, let us say 7. Can you help me? How will
Minus
you do
7.
it? Yeah. So next step
So
will be what?
then it would be x squared plus, and since 3 is not a perfect square, sir, we're gonna have to find, we're gonna do 3x
3
plus
by
in
2 whole
brackets
square.
3 divided by 2 whole square minus 3 divided by 2 whole square minus 7.
Yes.
Sir? And then since we use the 3, then it would be like x squared plus 3x plus 3 over 2 divided by that. We are just going to get in brackets x squared plus 3 over 2 whole square minus 9 over 4 minus 7. So that would just be...
If I use minus, both become positive, right? 9 plus
Yes, sir.
28. So that is 34, 37, right? 9 plus this is 37. Do you see that?
Yes, sir.
So that becomes the vertex form. And from here, you can say, what is the vertex now? Vertex is at -3 by 2.
And minus
And
37 over 4.
that is your minimum value, right? So we get the vertex, and this opens upwards, correct?
Yes, sir.
So we have a minimum value -37 by 4. Is that clear to you?
Yes, sir.
Let's
And
take one more
from that,
example.
we can also illustrate that where the graph has shifted, right, sir?
Yeah, that's vertex. So, okay, let's take one more example. This time, simply, I will take y equals to minus. Let me take now a value as not equal to 1, but let's say -1 for now. So if I have minus x squared plus, let's say 3x, okay, we have already used the value 3. Let's take 6x, 6 also we used, 5x, plus, let's say 1. Now, in that case, we should factor out minus, because we want the coefficient of x as 1, right? Not
Yes,
even
sir.
-1. So we factor this out and we get x squared minus 5x plus 1. I would like to keep this one separate, since in between I have to use the value 5 by 2, correct?
Yes, sir.
So we have x squared minus 5x plus 5 by 2 whole square minus 5 by 2 whole square plus 1, correct? Now, the three terms here form a perfect square, and therefore, we could write this as x minus, since this is minus, right? 5 by 2
Yes, sir.
whole square And that is minus 25 over 4 plus 1. Open the bracket. So you get minus x minus 5 by 2 whole square. And this minus and minus becomes plus 25 over 4 plus 1. Do you see this? Is this step clear to you?
Wait, sir, so what you did was from there on, right, sir? You changed the
Multiplied with minus, right? So this becomes negative and that becomes positive. Is that okay?
Wait,
now,
sir, but since you put it like you do the arrow into the small brackets, right, sir? Wouldn't it be x plus 5 over 2?
No, I mean it gets multiplied here, right?
Oh, okay.
The whole bracket, say minus outside. So we have minus of x minus 5 by 2. And when you add them, you get what? You get 4, 25 plus 4, correct? So let me rewrite my expression, which is y equals to minus x minus 5 by 2 whole square plus 29 by 4. Is that clear to you?
Yes, sir.
So from here, we can write down the vertex, which is what? 5 by 2, negative value of this, and
29 by 4.
Now this is the maximum value. Why is it maximum value?
Because A is negative, so it tells us it's opening downwards.
Correct. Is this clear to you?
Yes, sir.
So the axis also goes through the x value of this, right? So the axis, you can write axis of symmetry is that x equals to the x value, which is 5 by 8. Is that clear to you?
Yes, sir.
Perfect. Now what we are going to do is we are going to take an example where a is not equal to 1, because this is clear to you, right?
Yes, sir. So like greater and less than 1.
Yeah, not equal to 1 we'll take, right? Let me clear the screen and say, let us say we have this equation where y equals to 2x squared plus, let's say minus 8x minus 3. Okay. So we have this particular equation. Now here, as you can see, that x is not equal to 1, right? It is equal to 2, right?
Yes, sir. So it tells us it's going to be vertically stretched.
Yes. So yeah, a value is 2. That means the steps are?
It's going to be
2 times
2,
3, 5, 7.
2, 6, and 10.
Yes. So that will help you to get steps. But we have to get the vertex first. What vertex do you expect? Minus b by 2, right? So axis of symmetry should be at minus b by 2. It should be actually minus b by 2a. We will see it now, okay? So it is actually minus b by 2a, since we have a not equal to 1, right?
Yes, sir.
So let us see how do we get this term. So first step is we will take 2. Last time we factored minus, you remember? This time we factored 2. So when you factor 2, we get x squared minus 8 over 2x. I mean, I could have written 4 here. Let me rewrite this. X squared minus 4x minus 3, correct? So we divided 8 by 2. We factored out 2. Now the next step will be, as we did, you see this, now x has got coefficient of 1 only, right?
Yeah.
So we will apply our method. We get what? X squared minus 4x. Half of 4 is 2. So we'll add 2 squared and subtract 2 squared. And then we are going to do it, correct? So we have a perfect square here, which is x minus 2 whole square. And minus 2 squared is 4 and minus 3, right? Open the bracket. When you open the bracket, you get 2 times x minus 2 whole square minus 8 minus 3. So we have 2 times x minus 2 whole square minus 11, correct?
So you got a 2 in bracket multiplied by x minus 2 whole square minus 11, sir?
Correct. So what is the vertex?
Then the vertex would be 2 and negative 11.
Correct. Axis of symmetry.
So our B
Which is
value.
2, right? So this is axis of symmetry, right? X value, correct? And
Yeah,
you see, it is actually minus of B by 2A. So if I substitute minus, here it becomes minus of minus 8 is plus 8.
Plus
Divide
8.
by 2 times 2, which is 4. So 8 divided by 4 is 2. You see that we got 8?
Yes, sir.
Right. And in this case, because the parabola opens upwards, we have a minimum value. Is it clear to you?
Okay, sir. So, sir, basically what you did first of all, when it's greater, so you divided the x within the big
Minus
square
11.
brackets.
Sorry, minus 11. Minus 11.
Yes, sir. For this one, for the first, what you did was during the standard equation, you first divided your bx into half, and then after doing that, then you divided it even more into the exponents of 2 to the power plus minus the same amount. And then from there on, you started transitioning it to vertex and then solving for vertex by bringing out the left out the -4, multiplied it by 2 for both of them, right, sir?
Let's take one more example. And this time I'll take fractions, okay? So y equals to, let's say, minus half x squared plus, let's say, 3x minus 4. How will you do this? Tell me the steps involved.
So first we would isolate -half. So it would just be -half in square brackets x squared plus 3 divided by 2, sir.
Divided by half. 3 divided by half becomes 6. So when you take minus outside, then the sign changes. Do you see that? The sign will change because we have taken minus outside, correct?
Okay, sir.
So, and minus half means you're dividing 3 by half. So it means 3 times 2, which is 6, correct?
Yes, sir.
So that is what you're going to get as shown on the screen. Now you continue with the process. Can you tell me the next step, please?
Then from there on, it will be -half in square brackets x squared minus 6x plus 6/2 whole square minus
3. So I'm writing directly 3, right?
3 squared minus 3 squared in square brackets -4. And then from there, it would just be -half in square brackets. And from there in brackets, x minus 3 whole square and minus 9.
Yes.
In square brackets -4. And then from there on, it's just -half in curved brackets x minus 3 whole square. And since half of 9 is 3, so half of that is 9/2, then it'll just be plus 9/2 minus 4. So it would just be -half of x minus 3 whole square plus 9/2 minus 8/2. So it would just be -half brackets x minus 3 whole square plus half.
You're right, plus half. Clear? That was slightly complicated. We took minus half as the coefficient of x squared. The parabola is going to open downwards. And the stretch factor, you know, is now minus half. But first, let us write down the vertex. So what is the vertex here? Tell me.
It would be 3 and 1/2.
Correct. Axis of symmetry.
It would just be 3, sir.
Correct. And the maximum or minimum, what do you get?
Since it's opening downwards, it'll be maximum.
Value is half. Is it okay?
Yeah.
So parabola will look like what? It is going to open like this, correct?
Yes, sir.
So we can put a point on the vertex, and this point is 3/2.
3/2. And it's also vertically compressed as well.
By a factor of half. So steps you mean to say, right?
Yeah.
The steps are -half times 1357, correct?
Yes, sir. So it should just be -half minus 3/2
the next
minus
step will
5/2.
3. And when I do -half from here, so half minus half is 0, right?
0.
So at 3, you have x-intercept. Do you see that?
Yes, sir.
So at 3, you have y-intercept. So this is, it doesn't match. Let us check. Let us check. Because if I put 3 here, the y value is 0. So this is the x-intercept. Yeah, that's fine. Yeah. So if you draw the graph, it will kind of like this. Is that okay?
Yes, sir.
And the other one will be at 2, right? Because of symmetry, right? Do you see that?
Yes, sir.
I mean, this x-intercept will be at 2. Sorry, 2. Wait, let me just redo.
But wouldn't the x change, sir, for if it's were to be 0?
Yeah. And let me write. Yeah. So this point is at 2, right? So this is 2, 0. And so x-intercept, x-axis will be, so 3, 2, 1, somewhere on the right side. I mean, left side of this, somewhere here, correct?
Yes, sir. So this is actually like doing a strategy base other than just writing points down like the X, making a chart and then solving for each point, right, sir?
Yes. So from the vertex, we can go down and sketch the whole graph, right? So once you put the vertex there, which is 3.5, then you move one step and then figure out the whole graph, right? Do that addition of
Yes,
steps,
sir.
and you get your result. Is this process absolutely clear to you?
Yes, sir. It is clear to me.
Perfect. So that is how you are going to sketch the parabolas using the vertex from the standard equation. Now let me take one test question with you. So this time I'm taking slightly more complicated, minus, see 3 by 2 I'm using here, x squared, right? Plus, let us say the value here is, let's say 9, okay, x.
9.
And let's say plus, we have some value, let's say 4. Can you tell me how to do this, right?
So first we would write -3/2 in square brackets x squared minus 9x.
9 times 2/3. 9 times.
Yeah, 9 times 2/3.
And we'll keep this 4 separate. Do you understand this step?
Yes, sir.
Now let's simplify this. So that goes 3 times 2, 6, x plus 4. So now we have minus 3 by 2, x squared minus 6x.
So -3/2.
So half of 6 is 3. We get 3
x squared minus 3x squared plus
Is this absolutely clear to you? Now,
yes, sir.
What will be the x minus
-3 squared
and minus 9?
-9 and then plus 4.
Open the bracket. Multiply this, it becomes plus, right? So 9 times 3 is 27 over 2 plus 4, correct? Now, we are going to write this as y equals to minus 3 by 2, x minus 3 whole square. Let's do this. Plus 2 comma 27 plus 8. We have minus 3 by 2, x minus 3 whole square plus 27 plus 8 is 35. So with fractions also, very easily, we got our equation in the vertex form. Do you see that? So where
yes,
we have the vertex form. Correct?
Yeah.
Can you tell me what is the vertex?
So vertex would be 3 and 35/2, sir.
Axis of symmetry.
Axis of symmetry is 3, sir.
Maximum or minimum?
It would be maximum because it's opening downwards. So 35 divided by 2.
Correct. Steps.
And it is, I think, vertically stretched, sir?
Yes, vertically stretched by a factor of
One
-1.
and
And also reflected, right? And the
Yeah.
steps are 1, 3, 5, 7. Is it okay?
Yes, sir.
So that is how we are going to do it. Is it absolutely clear to you?
Yes, sir.
Perfect. So I hope you have understood the whole process, correct? So we'll actually close it here and I'd like you to summarize the learnings today, okay?
Okay,
Now,
sir.
can you explain me how did we convert the quadratic equation in standard form into the vertex form? Tell me the steps involved in it.
So first, what we did was for like a equal to 1 or greater than 1.
If it is anything, if
Okay.
A is A, you factor out A, correct?
So first, what we did was during the transition of from standard form to vertex form, we first had to analyze our equation, and when doing so, we actually reduced our b value by half
Correct.
to get our answer. So that would be like whatever our b was by adding the reduced value and squaring it, subtracting the same amount. And then from there on, we started converting our A, whatever our A was, like original B1, we divided by half and then we put it with our x squared and we left A out of the bracket. And then whatever was left over of the negative, we subtracted it with, we added with our C, added, subtracted with our C. And from there onwards, we got what our K value would have been, or also the Q value.
Yes.
From there, and by doing that, we have changed from standard to factored form.
Perfect. Let me again
Vertical.
get back to the whiteboard and show you quadratic formula from this calculation. Okay. So we'll start now with the general equation, which is y equals to ax squared plus bx plus c, correct? So once again, Rohan, our steps were, we have to take a common, correct? So we factor out a. If you do that, you get x squared plus b by ax, right? And you keep the c separate. And now
Yes, sir.
this step is a times x squared plus b by ax. We have to add and subtract half of coefficient of x, which is b by 2a now, correct? Minus b by 2a whole square, bracket close, plus c. Now, as you can see, the first three terms are perfect squares, and they can now be written as x plus b by 2a whole square. And we are left with minus b square, and square of 2a is 4a square, correct? Plus c.
Yes, sir.
Now let us open the bracket, multiplying a with both the terms, this term and this term. Is it okay? So you get
Yes,
a
sir.
times x plus b by 2a whole square minus a times b square over 4a square plus c, correct?
Yes, sir.
Now you can see, I can rewrite this as equal to a times x plus b by 2a whole square minus, you see this a cancels with this a square.
Yeah.
We get minus b square over 4a plus c, correct? Now let's rewrite this, combining the two constants. Those are constants. A times, they do not have x in it, right? X plus b by 2a whole square. And what do you get here? We get plus, we have minus b square plus 4 times ac, taking common denominator of 4a. Is that clear to you?
Yeah.
So we get a vertex form, which is y equals to a, x plus b by 2a whole square plus minus b square plus 4ac over 4a.
Over 4A.
Oh,
Oh, 2A.
4a. Sorry. 4a.
Oh,
Is this clear to you?
yes, sir.
So that is how we get a general form of vertex, correct? Now this is very useful to find solution of an equation also. Solution of an equation means what? Solution means if y equals to 0, find the value of x. That is the x-intercept, right?
Yes, sir.
So can you tell me how we'll find x-intercept with this, using this formula? We'll equate y equals to 0 and solve for it, correct?
Yes, sir.
Okay, so you have written down this formula, a times x plus b over 2a whole square plus minus b square plus 4ac over 4a, right?
Yeah. Yes, sir. Head
How
down.
do we solve this equation further? So I'm clearing the screen, and we have now written the formula as y equals to, can you tell me what was it?
A in brackets x plus b divided by 2a and whole square minus b plus 4ac divided by 4a.
Correct?
Yeah.
This is what we get. Now, to find the x-intercept, what are we going to do? We are going to do y equals to 0.
Y equals
Y
0.
equals 0 here. So I get 0 equals to a times x plus b by 2a whole square plus we have minus b square plus 4ac. I could actually write this in a way negative outside. No problem, right? Minus if I do here, I get b square minus 4ac. Is that okay? Over 4a, correct? So I took minus instead of plus. Now, since it is 0, I will take this constant term to the left side. So I get b square minus 4ac over 4a equals to a times x plus b by 2a whole square, correct?
Okay, sir.
Now divide by a. So we have b square minus 4ac divided by 4a square equals to x plus b by 2a whole square. Is this clear to you?
2a whole square. Okay, sir. So how did you get a squared though, sir?
I brought this a down, correct? So a times a is a.
Okay, sir.
Now I'm going to do square root both sides. Correct? So when you do square roots, you have to do plus and minus. So let me see. So if I have x plus b by 2a whole square root, I'll get what? I get x plus b by 2a, correct? Square root of square is absolute value. And on the other side, plus and minus, I get square root of b square minus 4ac over 4a square, correct?
Plus minus square root of b squared plus 4ac minus divided by 4a squared, sir?
I just swapped the x and y thing because I want to isolate x, right? So now I can isolate x. So x is equals to, I'll take this on the other side, minus b by 2a plus or minus square root of b square minus 4ac over 4a square. Is this clear to you?
So b squared minus 4ac divided by 4a squared.
What is 4a square square root? It is 2a, correct?
2a.
Do you see a very familiar formula?
Is it?
That is
I don't
the
think I've
quadratic
learned.
formula.
Oh, I never learned that, sir. That's why.
So, okay, so this x is equal to this. This is called quadratic formula.
Okay, sir.
So If you are given any equation standard form, you can find the x-intercepts easily by using this quadratic formula. You get the idea?
Oh, yes, sir. So basically what you did, sir, was from converting standard form to vertex form, you got your vertex form out, and then from here you did vertex form to quadratic formula.
Yeah. I'll show
And
it.
you can also do it back as well, right, sir? Backwards.
Yeah. So now I'll just take up an example to make things absolutely clear, okay? So let's take up an example. Let's say we have an equation y equals to 2x squared minus, let's say 4x, let's say minus, let's 6. Okay. So now in this particular case, if I use my formula, that is to say, I want to find solution of the equation. Right? So in this case, what is the value of A? 2, right?
2.
B, 4, correct?
4.
C minus 6, correct?
6.
So we have the solution, which is x equals to minus b plus minus square root of b square minus 4ac over 2a, correct?
B squared minus 4ac divided by 2a, right, sir?
Correct. So here...
So you just substitute all of the a and b?
Yeah, so b is minus 4, so it will be 4, right? Plus minus square of b minus 4 times a is 2 and c is minus 6, correct?
Minus 4 whole square minus 4 bracket 2 minus.
So you can calculate 4 plus or minus square root of 16. And this is 8 times 6, 48, right? Plus 48 over 4, correct?
16 plus 48, sir, over 4.
How much it is?
So 4 plus minus square of 6. So I got 1 plus minus 2.
Oh, okay. Correct? So basically we get the value of x as 1 plus 2
or 1 minus 2.
Minus 2, right? So 1 plus 2 is 3 and 1 minus 2 is minus 1. So for these
so this
two
is
values,
the intercept
it is 0. These are the x-intercepts. Can you check? If you put x as 3 or minus 1, what do you get?
If it's 3, 9, 18, minus 12, 6, minus 6, 0. And if negative 1, it's just 1, 2, 3. So for 3, I got 0. And for 1, I also got 0.
Yeah, so this is like 2. That is plus 6, plus 4. And this is minus 6, you can see. So both are the x-intercept. So without doing that, completing the squares and all that, directly we found the x-intercepts from the standard form. You see that?
Yes, sir. So what you did was from whatever you got your answer, sir, you put it into the intercept form, right, sir? And that was y equals in brackets x minus r brackets x minus s.
Correct. So if you want, you could factor this. I took a very simple equation. So if I factor 2 out, then you have what? You have got x squared minus 2x, and this is minus 3, right? And that could be factored as, now we need sum and product of minus 3 and sum of minus 2. So you get minus 3 and 1. So x minus 3 times x plus 1 as in the factored form. So that factored form will also give you the same zeros very easily. You see that?
Okay, sir. Because what you did was you first reduced you first brought A outside, and in brackets you reduced your B and C, and then from there onwards, what you did was you square rooted X to get X, and then you put -3 and +1 as the R and S values.
So is that clear to you?
Yes, sir.
So if you have understood this, I had another lesson with a student, and I'll share that video with you. You can actually look into that video and then practice questions from there, okay?
Okay,
so, okay, so let me just find this out. So let's just share. I'll go to YouTube. Can you do on your video, on your?
Yes, sir, I can do it.
So just go to my YouTube channel.
I'm just going on YouTube, sir. Yes, sir, what is it?
I just write Anil Kumar, graph quadratic or graph parabola standard equation. Search. So we're going to see how do we graph a parabola from standard form of quadratic equation.
All right. I got a few searches, sir.
Yeah, you can share the screen. I'll tell you which one.
Yeah, the first one.
Oh, there are so many. Go down, go down. There are so many, right? Yeah. There's so many. Okay. Continue. Yeah, so likewise, you see, we are done completing. Here, take this Abhinav Math 2. Click this one.
This
Abhinav
one,
Math.
right?
Yeah. This is a very interesting video. Yeah. So he shared with me his worksheet, and then we worked on it. And there are many questions in that particular worksheet. You can actually try them out. Is that okay?
Yes, sir.
So let's go through it. So for example, you can pause the video now. Yeah, check that question.
Oh, wait, and back?
Okay, we can go slightly ahead. Yeah, we can go slightly ahead. We'll start with that question. Yeah, that's okay.
So like...
Run the video. Yeah.
Okay.
So there are many questions here in the worksheet. We'll do the very first one, which is actually complicated since it involves fractions, okay?
Okay, sir.
But we need to graph all these equations which are given in standard form. Yeah.
Okay.
Pause
this
the
one, sir. This one, right?
Now we have
2x
the
squared
equation.
minus 3x.
Tell me what is the vertex?
So the vertex, it would be...
So we have this equation. So what is the vertex? Tell me.
Vertex, so...
Minus 3 by 2a, right? Minus 3 by
minus 3 by 2.
Right? So minus of minus 3. Minus of minus 3 divided by 2 times 2. A2, correct?
Yeah, so that would just be 3 divided by 4, sir.
Correct. So that becomes the x value of the vertex. Is that clear?
Yes, sir.
Now to find the y value, I'll have to substitute 3 by 4 and then find the y value, correct? So we also know axis of symmetry. So axis of symmetry is x equals
3 by 4.
3 by 4. Clear? Now let's find the y value. So substitute y will be 2 times 3 by 4 whole square minus 3 times 3 by 4 minus 2. Calculate. What do you get?
So that would be 2 multiplied by 9 over 16 minus 3 bracket. Oh, minus 1. Minus 2.
So that'll be 9 over 8 minus 9 over 4 minus 2. Common denominator 8. So get 9 minus 18. And 8 times 2, 16. And now you can combine, right? So get the answer. So 8 is the common denominator. 9 minus this is minus 9. And so it is minus 25.
Yes, I got the same thing.
Vertex will be at 3 by 4.
3 by 4 and negative 25 by 8.
8, yeah. Is that okay? So we get the vertex, and now you can sketch this parabola, correct?
Yes, sir.
So somewhere here, and then you can sketch it. Is it okay? Kind of like this. You get the idea.
Yeah, and it's also
very
opening
clearly,
upwards.
Y-intercept is minus 2, right?
Yeah.
And we know the vertex, and we can also follow the steps. The steps will be what? Steps will be
1, 3, 5.
1, 3, 5, 7.
So 2, 6, and 10.
Good. And you can now sketch it. You get the idea.
Yes, sir.
So using the formula, which we just derived, it is very easy to get the vertex from the standard form. Correct? I would like you to continue with this video. Do all the questions yourself. In case there is any difficulty, let me know, okay? And
Okay,
you can
sir.
also watch some more videos which you saw. So okay, we can stop sharing this. We'll end the class.
All right, sir.
Can you summarize what you have learned today?
So today what I've learned is how I can calculate the vertex and the axis of symmetry if A is equal or greater than 1, along with how to characterize and explain that the graph is vertically stretched or compressed by what factor. And along with that, being able to convert standard form to vertex form, along with now knowing the quadratic formula and how I can convert 3 of them back and forth.
Yes.
And also solving
Quadratic
basically, yeah, just the quadratic equations in general for standard form.
So in today's lesson, you actually learned everything about quadratic relations, how to work with their equations, how to find x-intercepts, which is also called solution in this case, right? And this can also help you to understand the transformation and sketch the graph, correct?
Yes, sir.
Okay, great. So we'll end this class here and we'll continue. And keep practicing from my videos. That'll be great, okay?
All right, thank you, sir. Have a great day.
You too.
Bye.